In this chapter, we are going to explain to you about Ethernet protocol, standard Ethernet, fast Ethernet, gigabit Ethernet, and 10 gigabit Ethernet.
There are two Internet protocols. There the IEEE Project 802 and Internet Evolution. IEEE Project 802 started in 1985 by the Computer Society of the IEEE. It was created to set standards to enable intercommunication among equipment from a variety of manufacturers. This image shows the relationship of the 802 standard to the TCP/IP protocol suite. Project 802 does not seek to replace any part of the OSI model or TCP/IP protocol suite. Instead, it is a way of specifying functions of the physical layer and the data link layer of major LAN protocols. Next is the Internet evolution. The Internet LAN was developed in the 1970s and already go through 4 generations. Let's check out all of these 4 generations.
The 4 generations are standard Ethernet with 10 megabits per second transmission rate, fast Ethernet with 100 megabits per second transmission rate, gigabit Ethernet with 1 gigabit per second transmission rate, and 10 gigabit Ethernet with 10 gigabit per second transmission rate. Let's go through the Ethernet evolution one by one. Standard Ethernet. Although most implementations have moved to other technologies in the Ethernet evolution, there are some features of the standard Ethernet that have not changed during the evolution. The characteristic can be shown with this frame. In this frame, it has preamble, SFD, destination address, source address, type, data, and padding and CRC. Preamble and SFD are the physical layer header. Preamble contains 7 bytes while SFD contains 1 byte. Destination address, source address, type, data, and padding and CRC are the frame length that contains 64 bytes, which has 6 bytes for destination address, 6 bytes for source address, 2 bytes for type, minimum 46 bytes, and maximum 1500 bytes for data and padding, and 4 bytes for CRC. Addressing. Each station on an Ethernet network, such as a PC, workstation, or printer, has its own network interface card. The network interface card fits inside the station and provides the station with a link layer address. The Ethernet address is 6 bytes, normally written in hexadecimal notation, with a colon between the bytes. For example, the following shows an Ethernet MAC address. Unicast can be declared as 0 and multicast can be declared as 1. These are the examples of how the implementation of standard Ethernet. Here, we have a local area network with a bus topology using a coaxial cable and a local area network with a star topology using a hub. Access method. The network that uses the standard Ethernet protocol is a broadcast network, so we need to use an access method to control access to the sharing medium. Efficiency of standard Ethernet. The efficiency of the Ethernet is defined as the ratio of the time used by a station to send data to the time the medium is occupied by the station. The efficiency of standard Ethernet is measured with efficiency equal to 1 divided 1 plus 6.4 multiple A. Implementation. The standard Ethernet defines several implementations, but only 4 of them became popular during the 1980s. This table shows a summary of standard Ethernet implementations. And these are how encoding works in a standard Ethernet. Here are 10 base 5 implementations that using thick Hozier cable with a length of 500 meter. These are the example of 10 base 2 implementation using thin Hozier cable with a length of maximum 185 meter. Next are the 10 base T implementation using 2 pairs of UTP cables. And here are 10 base F implementation using 2 fiber optic cables. Change in the standard. This change has opened the road to the evolution of the Ethernet to become compatible with other high data rate local area networks. The changes are including these aspects: sharing bandwidth, bridging, collision domains, switched Ethernet, full duplex switched Ethernet. In collision domains, the domain can be connected with a bridge. In switched Ethernet, one domain can be connected with a switch. And in full duplex switched Ethernet, node can transmit and receive data using a switch.
The next evolution is fast Internet. In 1990s, Internet increasing the transmission rate to 100 megabit per second, and they called the generation the fast Internet. The designers need to make it compatible with the standard Internet, so the match sublayer was left unchanged. But the features of the standard Internet that depend on the transmission rate had to be changed. As we know, the proper operation of the CSMA CD depends on the transmission rate, the minimum size of the frame, and the maximum network length. If we want to keep the minimum size of the frame, the maximum length of the frame should be changed. In other words, if the minimum size of the frame is still 512 bits and it is transmitted 10 times faster, the collision needs to be detected 10 times sooner, which means the maximum length of the network should be 10 times shorter. To be able to handle a 100 megabit per second data rate, several changes need to be made at the physical layer. The picture and table below shows the encode and the implementation of the fast Internet. The need for an even higher data rate have created Gigabit Internet Protocol 1000 megabit per second. The IEEE committee calls it the standard 802.3z. The goals of the Gigabit Internet were to upgrade the data rate to 1 gigabit per second, but keep the address length, the frame format, and the maximum and minimum frame length the same. A main consideration in the evolution of Internet was to keep the MAC sublayer untouched. However, to achieve a data rate of 1 gigabit per second, this was no longer possible. There's two distinctive approaches for medium access in Gigabit Internet: half duplex and full duplex. Almost all implementation of Gigabit Internet follow the full duplex approach, so we mostly ignore the half duplex mode. The physical layer in Gigabit Internet is more complicated than that in standard or fast Internet. As you can see here, the implementation of 1000 base SX, LX, and CX have the same encoder, that is 8D, 10B+, and RZ, while 1000 base T use 4D, PAM5. In recent years, the Internet for use in metropolitan areas had been upgraded. The idea is to extend the technology, the data rate, and the coverage distance so that the internet can be used as LAN and MAN metropolitan area network. The IEEE committee created 10 gigabit internet and called it standard 802.3L. 10 gigabit internet operates only in full duplex mode, which means there is no need for contention. CSMA CD is not used in 10 gigabit internet. The four of the most common implementations are 10G base SR, 10G base LR, 10G base EW, and 10G base X4. Here are the summary of the 10 gigabit internet implementations.
Okay, so that's all the topics we have in chapter 12. Hope you guys can remember and do not get confused with the evolution generation. Thank you for watching. Bye bye.